What we have in this spreadsheet are data from 20 countries for the year 2015. These come from the UN Development Program database, and the variable in column B is life expectancy in years, and the variable in column C is percent of the population that resides in an urban area. What I'd like to do here is to regress then life expectancy upon urbanization. Now the first thing we'll do to generate this regression model is I'll begin with the slope, and I'll use the slope function in Excel. Has the syntax of first of all highlighting the data array that contains the values for the y variable, comma, and then the data array that contains the value of the x variables, and hit return. And there we see a slope of 0.288. Now to find the intercept for this line, use the intercept function, and it has the exact same syntax as what we saw with the slope function. Highlight the array of y values, and then comma, highlight the array of x values. And right there we have the intercept. So the regression line that best describes these two data points is y equals 54.052 plus 0.288x. Let's also count the number of cases we have here. And I'll just use the count function. And there's also a function in Excel for computing the goodness of fit for this model, and that is the R-square statistic. It has the same syntactical structure as what we saw with the slope and the intercept functions. Highlight the array that contains the dependent variable, comma, highlight the array that contains the independent variable, and hit return. And here urbanization explains about 43% of the observed variation in life expectancy across these 20 countries. Now another way we could generate the R-square value if we have only one independent variable, which we do in this case, is to simply compute a correlation coefficient between these two variables. So I will use the Pearson function. This returns the Pearson product moment correlation coefficient, or Pearson's R, the typical measure of correlation for two quantitative variables. This has the same structure as what we've seen in some of the other functions here. Now, we just don't report the Pearson's correlation coefficient. What we do is we square the Pearson's correlation coefficient, so raised to the second power. And so that's another way you can generate the R-square value for this regression line if you only have one independent variable. And I should point out the R-square function, the slope function, and the intercept function that I just demonstrated also assume you only have one independent variable. What I'd also like to do now is demonstrate how we can use this information to compute predicted values for y. So I'll create a column label or heading of pred y, predicted y, and that's going to be nothing more than the intercept plus the slope times, and that's for the first row, the first case, the value of x for that first case, 73.05. So given the regression line we have here in a country that has 66% of its population that resides in urban areas, the line predicts then that the life expectancy at birth for that country would be 73.05 years. Now, to compute then predicted values for all the other cases here, I'm going to set the slope and the intercept reference to those cells. So now they're fixed, but I'm going to leave though the x value that's represented here by C2 as a relative reference, copy this down, and now we have our predicted values of y given the regression line for the individual values of x for each case. Now, another way that we can compute these predicted values is we can embed the slope and intercept functions into a formula. So for instance, we can start off with equal intercept parenthesis, and we'll do what we did before when we found the slope and the intercept. Highlight the y and x values respectively. We will add to that then the result of the slope function, and again highlight the y, comma, and x values for our cases. Close parenthesis, and then multiply that by whatever the x value is right there in that first case. And we get the same value of 73.05. Now, to copy this formula all the way down into the other cells, let me go ahead and make these relative references, but fixed references, not relative references, for what the data array we used for computing then the slope and the intercept. Now, this approach may be a little more trouble than it's worth, than given what we just did a moment ago, but I just want to show you that you can embed these functions into other formulas. And just fix that last column of x's with dollar signs in front. And hit return. We should have the same result. Now we can copy that down, and there we see we get the exact same predicted values. Now from here we could easily then compute residuals, and think about what a residual is nothing more than the actual value of y subtracting from that the predicted value of y for each of the cases. And there we see are the residual values. Now I could just go ahead and format these cells so they aren't reporting so many decimal places there. And those are prediction errors that we get from that regression equation. But let me go ahead and delete these values right here that we've got, because I want to show you another way, another function in Excel that can be used for generating predicted values of y. And this is the trend function. Now, the trend function does not require that we've already computed the slope and the intercept for a regression model. Instead, what it does is once you give it the y and the x data arrays, it will automatically internally compute the regression line and then generate the predicted values of x given the values of x you used in the routine. So, equal trend, open parenthesis. First of all, we'll highlight the known y's, comma, highlight the known x's, and that's what it uses to compute then the regression line, comma, and now I'll just click on a new x. So we're just going to be computing then the predicted value for that very first case, and hit return. And there we see the exact same predicted value we had before. Now if I wanted to copy this down into other cells, all I would need to do is to fix the known y's, fit the known x's, but I will leave as a relative reference the reference to the x variable that is used for computing the predicted value. So if I copy this down, I should get the exact same results that I had before, which I do. Now that's using the trend function as an individual formula in each one of the cells we have here. A more sophisticated way which we can use the trend function, and one which I think is really easier in the long run, is to use it as an array function. In this case, I've highlighted the output range where the predicted values for y will go. Now I will type in equal trend, the known y's, comma, the known x's, comma, now I identify the cases that I want, or the values of x that I want to use for making predicted values. And I want to use the exact same values we have here. Now you notice the fourth option here is the constant. If you do not enter in any information about the constant, it automatically generates predicted values, assuming that an intercept is used in the regression model, which is what we want. So hit return. Now before I hit enter, what I'm going to do is hold down the control and shift keys. And while I'm holding those down, I will push the enter button. And there you see it enters then that equation into all of those cases at one point in time and all those cells below. We know it has entered it as an array function. Is if we look up to the formula bar we see up above the spreadsheet, you notice that whole entire equation that I entered in is now contained in curly brackets. That indicates that it's an array function. If I wanted to delete that, I can't just highlight any one cell and try to delete it, because the entire range of cases, the entire range of cells, is that one array function. If I wanted to delete it, I have to highlight the entire set of cases where that function was entered in, and then I can hit enter, or delete rather, I should say, or backspace to delete that. But anyhow, that's how we can use the slope function, the intercept function, the R-square function, and all those three can only be used with bivariate regression, that is one independent variable, and also then the trend function for generating predicted values. Now, one of the things I should point out here that you can see is that with the slope and the intercept function, there is no information that's being used here, that is being reported here rather, that we can use in order to engage in hypothesis testing. So this does clearly have a limitation. But if you just want to generate a slope, an intercept, the goodness of fit for the bivariate model, and predicted values, these are functions you can very easily use to generate those results.